Okay, so here goes an example for practice 5. Mr. Nelson may have done this one on the board for you, but just in case you need it again. Hydrogen sulfide gas, which smells like rotten eggs, burns in air to produce sulfur dioxide and water. How many moles of oxygen gas would be needed to completely burn 8 moles of hydrogen sulfide? Okay, so the first thing we have to do is balance it. So let me get the pencil. Okay, so over here we have H, S, and O. We have 2, 1, 2. H, S, O over here, 2, 1, 3. Okay, so I see that my oxygens are odd and even, so I need to try to change this oxygen. So let me try to put a 2 here, because then that'll give me 4 oxygens and 4 hydrogens. Okay. And then let's see what else we can do here. So then now I've messed up these hydrogens, so I have 2 of these. So I've got 4 of these and 2 of these. Okay, now that messed up this one, so let me try a 2 there. So now I've got 2 of these and 4, 6 oxygens. Okay, and then I need to put a 3 here, so I have 6. Okay, all right, so I've got 2, 3, 2, 2. Okay, the molar mass. Hydrogen is 1.01 times 2, okay, and sulfur is 32.06. All right, so that's going to give me, you can be solving this out also, or hopefully you already did. Oops, if I can find the calculator, 1.01 times 2 plus 32.06. Okay, so I've got 34. I could have probably done that in my head if I wasn't so tired. 34.08 grams per mole. Okay, O2 I already just know is 32 grams per mole. Each oxygen is 16. Okay, O2 I know is 32, and S is 32.06, so that gives me 64.06 grams per mole, and water I believe is 18.02 grams per mole. Okay. All right, notice again, the coefficients doesn't matter, okay? So you're only finding the molar mass of the substance. The number in front doesn't matter to the molar mass, okay? This we're gonna add in later, probably next class, okay? All right, particle diagram, I have 2 H2S's, okay, and I have 3 O2s. Okay, and then 2 SO2s. All right, and then 2 waters. H, H, O, H, H. And here's a good chance to practice your balancing, right? I see 4 hydrogens over here, 4 here, 2 S's, 2 S's, 6, and 6, so I'm good, okay? All right, the ratios, this is the important step. For every 2 moles of H2S, it needs to react with 3 moles of O2 to produce 2 moles of SO2 and 2 moles of H2O, okay? All I'm doing here is I'm just looking at these coefficients to get the ratios, okay? That's it, okay? All right, now the hard part. Whoa, whoops. Can I get rid of that? No, how do I erase that? Like a go back button. Oh, beautiful. Okay, all right, so let's try the Bca table now. Okay, and the problem said that I started with 8 moles of hydrogen sulfide. Okay, and I'm going to completely burn it. Okay, so I have 8 moles. Okay, 8 moles of hydrogen sulfide, and I'm going to use all of it to give me 0. Okay, how much of the rest am I going to need? So if I have 8 moles of hydrogen sulfide, right, that's the thing that's going to stay the same in the change, because that's what all the ratios are going to be based on, because that was the given. Okay, all right, so now I need to look for my ratio. So I know here for every 2 moles of H2S I get 3 moles of O2. Okay, so this is going to be 12, so I had to start with 12 moles of O2 to get to nothing. Okay, this ratio, I'm going to go, I have 2 moles H2S is 2 moles of O2, Okay, so that's a 1-to-1 ratio, a 2-to-2. Okay, so I know I'm going to end up with 8 of those. I started with nothing. Okay, the products always start with nothing, and then I have 2 moles H2S, 2 moles H2O. Again, that's going to be a 2-to-2 ratio or a 1-to-1, so I'm going to get 8 moles of that. Okay, so if I react 8 moles of hydrogen sulfide, I need 12 moles of O2. I get 8 moles of SO2, and I get 8 moles of H2O. Okay? Right? Okay, and then dimensional analysis, this is the easy part. I'm just going to start with what's given, which was 8 moles of H2S. Okay, and the problem is really asking me for how many moles of oxygen gas is needed. Okay, so I'm actually looking at this column here. Okay, all right, so I know for every 2 moles H2S, I need 3 moles of O2. Oops, equals. Okay, because that is the ratio here, right? All these are ratios, okay? So for every 2 moles of H2S I need 3 moles of O2, okay? So that cancels. Cancel that to a 4, and then I just get 12 moles of O2, okay? Which is exactly the same as what I got right here, okay? So again, the dimensional analysis, it's really this change step, all right? It's just a little bit different way to solve it, okay?